Next up, we move on to placing all of the peripheral circuitry on the board. For each peripheral, I try to keep all of its related components grouped tightly together. This means that connectors, protection components, resistors, capacitors, and any supporting circuitry are placed close to each other, forming clear functional blocks on the PCB. Whenever a peripheral is exposed to the outside world, like UART, SWD, or CAN, we follow the same protection-first layout rule. That means ESD protection components are placed closest to the connector, followed by any series resistors or filtering components, and only then do the signals reach the MCU. For many peripherals, especially lower speed signals, the exact distance from the MCU is not extremely critical from a signal integrity perspective. Of course, this changes for high-speed interfaces, but for things like buttons, LEDs, and standard debug interfaces, placement flexibility is much higher. Because of that, I place peripherals primarily based on usability and accessibility. For example, the SWD header is placed where it's easy to reach with a debugger cable. The UART header is positioned so it's convenient to connect a USB to UART adapter. The reset button and GPIO button are placed along the edges of the board where they're easy to press during development. Similarly, the status LED is positioned where it's clearly visible, so you can immediately see whether the board is powered and running. This kind of placement makes the board much more pleasant to use during development and debugging. A dev board isn't just about electrical correctness, it's also about ergonomics and workflow. By keeping peripheral blocks compact, following protection best practices, and placing user interface elements where they make sense physically, we end up with a layout that is both electrically sound and easy to work with. Lastly, before moving on to routing, I do a full pass over the entire floor plan to make sure I haven't missed anything. This step is extremely important because it's very easy, especially in larger designs, to forget small but critical components. And in this case, as you can see, I actually did miss a few capacitors and resistors in the kicad transceiver circuitry. Catching issues like this early is exactly why this review step exists. It's much easier to fix missing components during placement than after routing has already started. Once all the components are placed correctly and nothing is missing, I then go through the entire board again and focus specifically on the silkscreen. I take the time to rotate and reposition all the reference designators so that they are readable and consistently oriented. This might seem like a minor detail, but good silkscreen readability makes a huge difference during assembly, debugging, and future revisions. If there's enough space on the board, I strongly recommend keeping all component designators visible on the silkscreen. It makes probing, troubleshooting, and rework much easier, especially when someone else is working with the board.